Welcome to English for Professional Mechanical Engineers. I'm happy to have the chance to speak to you today about microfabrication. My name is Yiju. In today's lesson, we will talk about the second topic of microfabrication, photolithography. Last video, we introduced the concept of microfabrication and how to prepare the wafers for semiconductor industry like TSMC, Taiwan Semiconductor Manufacturing Company. In addition, 3 categories of microfabrication techniques were introduced: patterning or photolithography, deposition, and etching. We'll focus on the first category in today's lesson. This is the outline for this section. First of all, let me start by the definition of photolithography. Next, we'll talk about a key material for the technology, photoresist or PR. Then let's take a moment to look at a few machines: spin coater, wafer aligner, and exposure tool. Alright, let's move on to the first part, photolithography. What does that mean? Okay, photo means light. Lithography means printing. As a result, the best meaning of photolithography means printing by light. Or, the formal definition is a process by which an image is optically transferred from one surface to another, most commonly by projection of light through a mask onto a photosensitive material. There are some key points over here. First of all is a process. Second, this process transfers image from one surface to another by light or photo. Finally, it needs a mask and a photosensitive material. What does that mean? A mask has an image which can be transferred from one surface onto another surface. But how does that process happen? Look at the outline again. It requires a photosensitive material or photoresist, PR. Firstly, a photoresist is a material that changes molecular structure when exposed to radiation, something like ultraviolet light. Secondly, it has 2 types of photoresists, positive and negative types. A positive photoresist is weakened by radiation exposure. As you may see the figure on the left, the brown layer is photoresist. The layer on the top of photoresist is a mask. This part of photoresist under the transparent region of the mask will be weakened by the light exposure. As a result, the final photoresist layer with radiation will disappear, while the other part of photoresist without radiation exposure is strong and remains on the top of the silicon wafer. On the contrary, a negative photoresist is strengthened by radiation exposure. As a result, the part of photoresist with radiation exposure will be stronger and remains, while the other part without radiation exposure will disappear. So, 2 types of photoresists are both sensitive to light, but one will become stronger with radiation exposure, while the other one is weaker by the same light exposure process. Now, what's next? We have introduced the concept of photolithography and the key material photoresist in the process. Next, we will move on to some machines in the microfabrication: spin coater first, then wafer aligner and exposure tool. Here is a photo of a spin coater using in NCKU 成功大学 clean room. The purpose of a spin coater is to spin photoresist layer on the wafer. This photo shows a blue silicon wafer on the bottom with a dispenser on the top. The dispenser distributes photoresist uniformly on the wafer. Then the machine will spin or rotate. As a result, the liquid photoresist will form a uniform thin coating layer on the surface of the silicon wafer. So, first, liquid photoresist is dispensed on the surface. Then, the machine spins. Finally, a thin fine layers of photoresist is coated on the surface of silicon wafer. Right. Was that clear? Let's look at the next figure. This figure shows the other machines for microfabrication, wafer aligner, and exposure tool. They are also in the NCKU clean room. The purpose of a wafer aligner is to align the position of a mask in a silicon wafer. After the position of a mask in a silicon wafer is well aligned, the exposure tool can expose the photoresist through the mask with the proper light. As a result, the combination of wafer aligner and exposure tool is to transfer the pattern of the mask into the photoresist. Again, the whole process is demonstrated in this figure. When the mask is aligned well on the top of photoresist, an ultraviolet light source can transfer the mask pattern onto the photoresist. The light source for the exposure could be mercury or xenon lamp, excimer laser, electron beams, or X-ray. The energy of exposure is crucial and can be calculated by light intensity multiplying the exposure time. Finally, let's reflect the main points of this section. This is the outline of today's lesson. It includes the meaning of photolithography, function of photoresist, and some machines in microfabrication, including spin coater, wafer aligner, and exposure tool. Next, we are going to have some questions to summarize the key points of this section. Question of photolithography. True or false? Photolithography means printing by knife. Okay, the answer is false. Photo means light. Lithography means printing. As a result, photolithography means printing by light. So it's by light, not by knife. Or we can look at the formal definition again. Photolithography is a process by which an image is optically transferred from one surface to another. Does that make sense to you? Good. Let's move on. Question of photoresist. There are two types of photoresists. A positive photoresist is weakened by radiation exposure, while a negative photoresist is stronger by radiation exposure. There are two figures over here. Can you tell me which one represents positive photoresist and which one is negative photoresist? Okay, the left figure is positive because the photoresist with radiation exposure disappears. And the right figure represents negative photoresist because the photoresist with radiation exposure remains. Question of spin coating. What material is added by spin coating onto the wafer during the microfabrication? Alright, the answer is photoresist. The The purpose of spin coating is adding a photoresist layer onto the wafer. Next, question of exposure. What kind of light source can be used for photoresist exposure? This question is a multiple choice. A. Mercury and xenon lamp. B. Excimer laser. C. Electron beams. D. X-ray. Okay, the answer is all of the above. Have you guessed correctly? Good job. We have covered the materials including photolithography, photoresist, and the machines like spin coater, wafer aligner, and exposure tool. And this is the first category of microfabrication, photolithography. Next section will cover how to do deposition in microscale structure. So, this is the end of section Introduction to Photolithography. So much for today. Thank you for watching. Hope you have learned something useful from today's lecture. We are going to talk about another key point of microfabrication in the next video, deposition. Have a good time and see you in the next video. Goodbye.